All right, guys, so we're starting chapter 18 today. This is about exponential functions. This is a little bit different than what we've been doing. This is like a third parent function. We had linears, we had quadratics, now we have exponentials. The first four problems are really quick and easy, and they're just calculator. It says use the calculator to determine the approximate value of each expression to the nearest hundredth. That means 2 decimal places, and you need to round as best you can. But basically, I just put them all in the calculator. So this first one, I'm just going to put in 4, then to this caret button on the right below clear. I'm going to put in 1.7. I'm going to hit enter. It says 10.556. That would be 10.56. Since this 5 is preceded by 6, I rounded it up. Now we can go through the rest of them. Pretty much the same thing. I have 10 to the negative 0.5. Hit enter. I didn't put 10. How about 10 to the negative 0.5 and hit enter. I got 0.316, so I'm going to put my answer as 0.32. Let's see, the next one looks a little funny. It's 4, then in parentheses 3 to the 0.7, close parentheses, enter. I got 8.63. Then we have our last one over here. Let's see, that would be in parentheses 2 divided by 3, close parentheses, to the negative 1.2. If we do that one, we get 1.63. So guys, a lot of your homework's just like that. Should be pretty easy. Make sure you do it right. All right, let's go on. All the rest are going to be about graphing functions. This is going to be kind of a new parent function. When we did linears, every time we did a linear, it was a straight line. Every time we did a quadratic, something x squared, it was a parabola. These are going to look a little different because the x is the exponent. So I'm going to put this new equation, y equals 4x, into my calculator. I'm going to go to y equals, and I'm going to put 4 to the button right below clear, x. And I'm going to look at the table. Now, I don't want you to round these, just want you to write them out. Looks like at negative 2, I have 0.0625. At negative 1, I have 0.25. Then I have at 0, 1, then 4, and then 16. So I want to plot those points. At negative 2, I'm at 0.0625. That's almost 0, so I'm going to be basically right on the line. Then I have negative 1.25. That's also really close to 0, but a little bit bigger. Then over 0 up 1, over 1 up 1, 2, 3, 4. And then 2's at 16, somewhere way up here. Now, if you look at the calculator's graph, it looks like it kind of disappears around negative 1 or so. It doesn't actually disappear. I'm going to connect these and get my curve. But this line actually just goes along that axis, but never actually hits it. If you go back in the table, if I go back to second table and start going up, all those numbers are getting smaller and smaller and smaller, closer and closer to 0, but they never actually get there. If we talk about domain and range with these, domain's how far left and how far right it goes. If I look at either graph, it goes to the left forever, and it's going to keep leaning to the right forever. So the domain is all real numbers. But range is y, the up and down. The lowest I can go on this is 0, but I can go all the way up to infinity, so y is greater than 0. Now let's use that parent function. I kind of want you to notice, when we had the quadratics and we started transforming them, we knew we had that point 0, 0, and we could kind of move it from there. This one has a point that we're going to move at 0, 1. So when we do these transformations in a second, you kind of want to see where that moved to. Let's go on and do the next one. Now it's 4 to the x minus 8. So let's get out our calculators. All I really have to do is put a minus 8 at the end of that. I'm going to put it in a different one so we can look at it. 4 to the x minus 8. I'm going to change the way that looks a little bit. I'm going to look at the table. Wants me to tell them from negative 2 to 2, so I'm going to record those answers. At negative 2, and mine's in y2. At negative 2, I'm at negative 7.938. Then I'm at negative 7.75. At 0, I'm at negative 7. At 1, I'm at negative 4. And 2, I'm at 8. Now I'm going to look at the graph on my calculator. You can kind of see the difference. I'm going to graph this one also. Let's see, negative 2 is at negative 7.938, so really close to negative 8. So maybe about right there, maybe a little lower. The next one, now it gets closer and closer. Sorry, I had a little skip there. It says -8, but that's just so close to -8 that it doesn't know what else to put. So if I look at the original function, which kind of looked like this, the shape didn't change. The difference is I started at 0, 1, and now I'm at 0, -7. So what's the difference from this one to number 5? This was a shift down 8, which you should have recognized because we subtracted 8. These are just like the transformations that we did before. So -8 made me go down 8, plus 8 would make me go up 8. Let's go to the next page. Same sort of problem, except for now, whoops, now I'm not subtracting 1 from the exponent. So let's get out our calculators, make sure we put this in right. Now I'm going to put in 4 to the, but since the -1 is from x, you need to open parentheses, put x minus 1. And let's look at the table. I want it from -2 to 2 again, so I'm a little bit high up here. So at -2, golly, I'm having some troubles here. So at -2, we're at 0.01563. At -1, we're at 0.0625. At 0, we're at 0.25. Then we're at 1, and then we're at 4. So I'm going to graph those real quick. -2 is practically 0, almost right on the line. So's -1, those are both really small numbers, and 0 is really small, really close to each other. Then at 1, we're at 1, and then at 2, we're at 1, 2, 3, 4. So here's kind of what our graph looks like. It's going to go up like that. So that's just slightly different from our parent function. Our parent function looks something like this. So it didn't change any shape, but if you notice that pivot point we talked about earlier is now over here. The transformation was right 1. So guys, if it's down here, like in this space, that's an up-down shift. If it's connected to the x and the exponent, it's a left or right shift, and we've seen those before. Now let's look at the next one and see if we can predict what kind of shift it's going to be. I have 4x to the x plus 2 plus 3. So you can probably already see, we've already seen a transformation in the exponent and a transformation by adding or subtracting on the outside. Let's put this one in our calculator. Let's see, it's 4 to the, in parentheses, x plus 2, close parentheses. That'll automatically take you out of the exponent, then plus 3. So I'm going to look at my table here and I'm going to fill it out. Now this one starts at -4. At -4, we're at 3.0625. At -3, we're at 3.25. Then we go up to 4, 7, and 19. So I'm going to graph those points. Now if you look, -3 is 3.25. At -4, we got even closer to 3. And if we go up further, we're going to get even closer to that still. So let's go ahead and plot. -4, a little above 3. -3 is just a little bit above that last one. 2, or -2 is at 4. -1 is at 7. And then 0 is way up here at the top. So this one kind of looks like this. And if you notice, I mean, you can tell from the table, the line we're never going to cross is at 3. So when we did the range, it's going to be everything above 3. The domain didn't change, though. But we need to make sure we can see our transformation. Here's where we started. I had to go over 1, 2 to get here, and 1, 2, 3 to get back up to my pivot point. So that's going to be a left 2 and an up 3. This moves left to right. This moves up or down. So guys, they're basically the same thing as you've already done. The homework looks just like this. Make sure you graph them correctly. Look at your numbers when you get your transformation. Now let's look at another one. This one should be pretty obvious. Now we're putting in -4 to the x. So let's go ahead and throw that one in. I'm in y equals, cleared out, -4 to the x. Let's look at the table. It wants from -2 to 2. Well, at -2, we're at -0.0625. At -1, we're at -0.25. At 0, -1, 1's -4, and 2 is -16. Now, these numbers should sort of look familiar, because we've already seen them. They were just positive when we did it before. You should remember when we put in negatives, it's going to be a reflection of some kind. So let's see what this one looks like. At -2, I am almost at 0. I'm a little higher than that at -1. And then at 0, I'm at -1. Then at 1, I'm at -4. And then 2 is way down here off the graph. So it sort of looks like this. So this one, unlike the first one, this one can't go above 0. The parent function couldn't go below 0. So this ends up being a reflection. But it looks like it reflected this way, like flipped over. So that's over the x-axis. So you should know that because it's a negative outside, that it's a reflection over the x-axis. That's the same as the problems we've done before. Let's go to the back page and finish this up. We've got one more to look at. I have y equals 1/4 to the x. Be careful when you put this in y equals. It's got to be parentheses, 1 divided by 4, close parentheses, to the x. Now when I look at the table, for -2 I got 16. For 1, or -1 I got 4. 0 is still at 1. 1 was at 0.25 and 2 is at 0.0625. So guys, those are again similar to the numbers we had in the original one, except they're backwards. -2 was 0.0625, now it's 16. Let's plot those. At 2, I'm way up here. At -2, I'm off the charts. At -1, I'm at 4. At 0, I'm at 1. And then the next 2 are just getting progressively closer to 0. So there is my function. Now remember, the parent function looked more like this. So again, it is a reflection. But this time, it's flipping side to side, so this is over the y-axis. And guys, there's something you may or may not know. Whole numbers, numbers bigger than 1 to a whole number are going to get bigger and bigger. But if it's to a fraction, they get smaller. It's the opposite effect when you have a fraction for the base like this one. The bigger x gets, the smaller the answer is going to be. But the smaller or more negative x gets, the bigger it's going to get. So guys, their homework looks a lot like that. There's 4 problems at the end that say to factor completely. If you don't do those problems, it will take tons of work off your homework. I have people come in all the time saying, oh, well, I didn't know how to factor on the test. It's because we're not doing the review questions at the end of the homework. If you don't do them, you're never going to remember. Hope this helps out, and good luck.